Hello viewers, welcome to Sichinga Online Math. In this video we'll focus on question 16 A and B, which is coming from a 2021 paper 1 internal mathematics at grade 12. So this question has got two parts, A and B. Part A reads, find the equation of a straight line which is perpendicular to the line 2y minus x equal to 3 and passing through the point negative 4, 1. Then B, in the answer space below is an incomplete flow chart for calculating the curved surface area, which is denoted by A, of a cylinder with radius r and height h. Complete the flow chart. So for this part, we are going to fill up the flow chart, which is given in this form. So this is the flow chart we're going to fill up. There are two empty boxes here, so we'll discuss what should be in this box and also what should be in this box. So for now we go to question A, 16A. So 16A, we want the equation of a straight line perpendicular to 2y minus x equal to 3 and also passing through the point negative 4, 1. So how do we do this process? So first of all, we're going to work with this equation. This equation is going to give us its gradient. So we're going to use this equation to determine its gradient, and then we'll use this gradient so that we can get the equation which is passing through this point here. So it all starts with this equation. So we're going to change this equation in the form. We're going to change this equation in the form y is equal to mx plus c. Y is equal to mx plus c. Now, m is the coefficient of x and m is gradient of a line. So if we change this equation into this form, we're going to get m just by looking at the coefficient of x. So let's start the process. This is going to be 2y minus x is equal to 3. So we'll take x to the right side. This gives 2y equal to, this will be positive x, then plus 3. Then we divide by 2. Dividing by 2 both sides, this side the 2 will simplify, giving us 1, and 1 times y gives y equal to. So this denominator belongs to x and also to 3, so we can separate this as follows. Now also, before we separate that, take note, there is a 1 which is in front of x here, so we can write this as 1 over 2. Then x, then we say add to 3 over 2. So y is equal to 1 over 2x plus 3 over 2 is our equation if we put it in the form y equal to mx plus c. Now, what is the gradient of this line? So the gradient, we said it is m, the coefficient of x. So we'll denote this as m1. So we're going to say m1 is equal to 1 over 2. So the gradient of this line is 1 over 2. Okay, so now after finding the gradient of 2y minus x equal to 3, we're going to use this gradient to determine the gradient of the line that is perpendicular to this line. So the concept there is just this one. So m1, which is this one we got, multiplying by m2, which is the gradient that we want, the 2 give negative 1. So this is just a concept on perpendicular lines. So if two lines are perpendicular, then it means that the product of their gradient is equal to -1. So now we've got m1, which is 1 over 2. So this means we can substitute on m1. We're going to put 1 over 2. So we're going to say 1 over 2 m2 is equal to -1. So working out m2, 1 is multiplying with m, that is just giving us m2 equal to 2 is multiplying with the -1, so which gives -2 here. So m2 is equal to -2. If we get m2, then we are going to use the formula. We're going to use the formula y minus y1 is equal to mx minus x1. Now, what is y1? What is y1? What is x1? So y1, x1, it is just this point given. So we're going to use this point. We substitute into this formula. Also on m, let's be specific. This m that is here is m2. So we're going to use m2 on this one to be specific. So then what are we going to get if we substitute? So if you've seen the coordinate is -4, 1. -4, 1. So what is the value of x here? The value of x is this one. The value of y is this one. So we'll substitute like this. Y minus 1 is equal to m2. On m2 we'll put -2. Multiplying with x minus, so on x1 we put -4, so which is the negative here. So we'll multiply there. So then this will give us the following: y equal to, so we'll take -1 to the other side. So first of all, let's do the multiplication. -2 times x gives us -2x. Then negative gives a positive. -2 times +4 will give us a -8. So we're going to have y equal to -2x minus 8. Then let's not forget there is this one which we're saying we'll move it. So this means that this will be +1. So what do we get when we add -8 plus 1? So -8 plus 1 gives us y equal to, here we say -2x. So you keep the sign of the larger number, which is negative, and then subtract, which gives y equal to -2x minus 7. So this here is the equation of a line which is perpendicular to the line 2y minus x equal to 3. So that is the equation, y equal to -2x minus 7. So moving on, working out 16b. So for 16b, what we are looking at is a flowchart which is incomplete. So this flowchart, we're saying it's like this. So we've got start, empty box, which is the input box. It's empty, we need to fill up something there. Also we've got the action stage, which is also empty. And we've got this one, the output box, which has been filled up with the output A, which in this case represents the output of the curved surface area that we are looking for, and then stop. So now, if this is our flowchart, let's look at the information again. So we have been given that this flowchart is about calculating the curved surface area, which is A, of a cylinder with radius R and height H. So complete the flow chart. So to complete the flow chart, what we just have to take note of is the boxes that are missing. So the boxes are the input stage and the action stage. So what are we supposed to have in the input stage? So in the input stage, we're supposed to have variables that we are using to calculate the curved surface area. So what are the variables? So the variables are not even far away. It's just what we've been given in the question here. So we don't have to even look for them. They are just right here. So the variables, when you look at the curved surface area of a cylinder, it's the radius R and height H. Then what are we going to put in this box here? So in the action box, what we're going to put is the formula for calculating the curved surface area of a cylinder. So first of all, what we're just going to do is then remember what is the formula for calculating the curved surface area. So we want to first of all remind ourselves about how we calculate the curved surface area of a cylinder. So curved surface area of a cylinder is just given by the formula. It's just given by the formula C S A is equal to 2 pi R H. That is the formula for calculating curved surface area. But then in this case, they've said we are using the denotation A to denote curved surface area. So in place of all this, we're saying A is equal to 2 pi R H. And in this formula, there are two variables, as I said. So the variables are radius and height. The first two, 2 and pi, are constants. 2 is a constant and also pi is a constant. So meaning the variables that we have are R and H. So this means that in our input stage, the variables that we are going to use are R and H. So the language I'll use here, since they've used output for the output stage, then I'll also use something that is in line with this term. So which means here I'll use the word input. So what are we using in our input stage? So in our input stage, we are just putting in two values, which is R and H. So we'll just write input R, comma H. Input R, comma H. So these are the input values for the flowchart or for calculating curved surface area of a cylinder. Then in the action stage, we're going to put in the formula, but then we don't just show it the way it is being given here like this. Area is equal to 2 pi R H. So there are special characters that we use when we are using computers. So the character is known as the asterisk. Asterisk. So the asterisk is just this symbol here, like a star. So in place of the spaces in between, these will be putting the asterisk. The meaning of that is just multiplication. So we have multiplication between the constants and the variables. So this means that we'll put in this to show the multiplication. So this will mean that area is equal to, this is curved surface area, is equal to 2. So 2, then we'll say star or asterisk, then pi, then again asterisk, then R, then that, then lastly h. So this means we've shown multiplication of 2 times pi times r times h. So this is what is missing in our flowchart to make it complete for calculating the curved surface area of a cylinder. So thank you so much for watching this video. Look out for solutions to question 17 in my next video.